This problem is about heat release from reaction and finding the exit temperature for no heat removal. So this is about involving multiple reactions, heat of formation method and heat of reaction method. The terminology as given by Felder, and again finding the adiabatic exit temperature. Okay. For these two reactions, we are given with the heat of formation data, and also we are given with the feed and product moles and feed and product temperatures, and additionally we are also given with a CP data applicable over the range of temperature of the interest. Okay. Now, for the heat of formation method, simply Q equal to NiHA of products minus NiHA of reactants. Here we don't write anything about the heat of reaction or anything. They are automatically coming into consideration because of this HI is based on standard heat of formation plus CPI into delta T. Of course, if you have a CP as a function of temperature, put this as integral, this integral of CPI dt. And normally it will be available A plus BT CT square. In that way, it will be available, integrate that. But for simplicity, normally we take this average value. At least for the simple examination, normally we'll be giving it only CPI, CP in terms of constant value. Okay. Using that constant values given already, I'm calculating this HI, which is the addition of delta HF plus CP delta T. For the feed, there is at one temperature, and for one component it is at one temperature. The other two components, this air is at a different temperature, and this HI is available multiplied by Ni. Always look for the unit consistency. This is in moles, and this is in kilojoule per mole. So moles into kilojoule per mole, so you'll be getting in kilojoule. Fine, correctly. Likewise for product components, every components we calculate that. Then simply heat released equal to NiHA of products and NiHA of reactants. Use the signs properly. Okay, this is calculated. The next thing is for Q equal to 0. What is called as the adiabatic system? What is the exit temperature? So here you allow this, you have to find this exit temperature. Earlier we were given, now this were given, Q is given, and we are finding the exit temperature. Okay, coming to the other method, what is called as the usual method, what we follow, that normally we follow for a single reaction. In that case, not such consideration. We need not worry about the extent. We can simply do that. But for multiple reactions, better to work out this extent of reactions and solve. Here, of course, heat of reaction is sigma nu I HI, HFI. Okay, there is a heat of reaction definition. There is simply heat of formation of products minus reactant with proper multiplication of stoichiometric coefficients. Okay, now for every reaction, heat of reaction is calculated. Standard heat of reaction is calculated, and we have this moles and CP delta T for feed, and product we have. Product is available at 150 degrees Celsius. For that also we have calculated. Additionally, I also calculate this NiCPI because I also sometimes I need to find the adiabatic temperature as well. So okay, first thing is substituting everything. We got this value. If there were no heat removal, T exit will be definitely higher than 150 degrees Celsius. So that we are going to find. So this NiCPI for the products is summation is available, and this T minus T reference, T is nothing but the exit temperature that is obtained by solving this.